if A is equal to the matrix minus 1, 5, minus 2, 2, 7, 1, 3, 9, 1, and B is equal to the matrix minus 4, 1, 1, 1, 2, 3, minus 5, 0, 1, then verify that the first sub-question is A plus B transpose is equal to A transpose plus B transpose, and second is A minus B transpose is equal to A transpose minus B transpose. So let us do one by one. So here your LHS are A plus B whole transpose, so that should be equal to your A transpose plus of B transpose. Similarly, A minus B transpose should be equal to A transpose minus B transpose. So the given matrix A is equal to, say, minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. So let me find the A transpose. So A transpose will be, so changing the rows and columns. So your first column becomes your first row, minus 1, 5, minus 2. Second column as second row, 2, 7, 1. And third column as third row, 3, 9, 1. This is the transpose of matrix A. So similarly, we have the matrix B, which is minus 4, 1, 1, 1, 2, 3, minus 5, 0, 1. This is the matrix B. So then B transpose will be equal to, interchange the rows and columns. So the first column of B becomes the first row, minus 4, 1, 1, and second column will be your second row, 1, 2, 3, and the last column as last row, minus 5, 0, 1. So this is B transpose. So let me solve one by one. So your first sub question is A plus B whole transpose is equal to A transpose plus B transpose. So let me consider first A plus B. So add two matrices. So both are a 3 cross 3 matrix. We can add the corresponding elements. So the result will be, the first element we have minus 1, corresponding element is minus 4. So minus 1 plus 4 will be minus 5. Second element is 2, corresponding element is 1. So 2 plus 1 is 3. Third element is 3, corresponding element is minus 5. So 3 plus of minus 5 is minus 2. Next, in second row, first element is 5, corresponding element is 1. So 5 plus 1 is 6. Second element in the second row is 7, corresponding element is 2. 7 plus 2 is 9. And last element in the second row is 9, corresponding element is 0. 9 plus 0 is 9. And in the last row, we have first element minus 2, corresponding element 1. So minus 2 plus 1 will be minus 1. Second element is 1, corresponding element is 3 in the last row. So 1 plus 3 is 4. And the last element is 1, corresponding element is 1. 1 plus 1 will be 2. Is sum of two matrices. So in LHS we have A plus B whole transpose. So we have found A plus B. Let me take A plus B transpose of it. So we know the A plus B matrix. Take the transpose of it. So we have to interchange the rows and columns. Your first column will becomes your first row, or your first row becomes your first column. So let me consider the first column, which is minus 5, 6, minus 1 becomes your first row. Minus 5, 6, minus 1, and second column as second row 3, 9, 4, and the last column as last row minus 2, 9, 2. Call this as 1. So this is your LHS. In RHS we have A transpose plus B transpose. So consider A transpose plus B transpose. Initially we have found A transpose and B transpose. Let me add these two matrices. So we get the first element in the first row is minus 1, corresponding element is minus 4. So minus 4 minus 1 will be minus 5. And we have second element 5, corresponding element 1. 5 plus 1 is 6. And the last element in first row is minus 2, corresponding element is 1. So minus 2 plus 1 is minus 1. In second row, first element is 2, corresponding element is 1. So 2 plus 1 is 3. And second element in the second row is 7, corresponding element is 2. 7 plus 2 is 9. So last element in the second row is 1, and the corresponding element is 3. 1 plus 3 is 4. Last row, first element is 3, corresponding element is minus 5. So 3 minus 5 is minus 2. And second element is 9, a corresponding element is 0. So 9 plus 0 is 9. And the last element is 1, corresponding element is 1. So 1 plus 1 is 2. So call this as equation 2. So from 1 and 2 we can say both are equal. From 1 and 2, this A plus B transpose is equal to A transpose plus B transpose. So this is your first sub-question. The second sub-question is A minus B whole transpose is equal to A transpose minus B transpose. So to prove this, first we consider A minus B. So let me subtract these two matrices. So the result is the matrix. So first element we have is minus 1, corresponding element minus 4. So minus 1 minus of minus 4 is 3. Similarly we have the second element 2, corresponding element 1. So 2 minus 1 is 1. And the third element is 3, corresponding element is minus 5. So 3 minus of minus 5 is 3 plus 5, 8. Now the second row, first element is 5, corresponding element is 1. So 5 minus 1 is 4. Second element is 7, corresponding element is 2. 7 minus 2 is 5. And the last element in the second row is 9, corresponding element is 0. So 9 minus 0 is 9. And the last row, first element is minus 2, corresponding element is 1. So minus 2 minus 1 is minus 3. Second element in the last row is 1, corresponding element is 3. 1 minus 3 is minus 2. And the last element in the last row is 1, corresponding element is 1. So 1 minus 1 is 0. This is your A minus B. So let me take the transpose of it so that we get the LHS. So A minus B whole transpose is equal to, interchange the row and column of A minus B matrix, which is 3, 4, minus 3, 1, 5, minus 2, 8, 9, 0. So call this as equation 3. This is your LHS of second subquestion. So let me find the RHS. So in RHS we have A complement minus B transpose, A transpose minus B transpose. Subtracting these two, we get minus 1 plus 4 is 3, and we have 5 minus 1, which is 4, and we have minus 2 minus 1, which is minus 3, and we have 2 minus 1, 1, 7 minus 2, 5, 1 minus 3, minus 2, and last row is 3 minus of minus 5, which is 3 plus 5, 8, 9 minus 0 is 9, 1 minus 1 is 0. So call this as equation 4. So compare equation 3 and 4. The elements of matrix both are equal. So we can say from 3 and 4, A minus B whole complement is equal to A complement minus B complement.